Hello, class. This will be section 2.3, which is the start of concept 2, and we'll be talking about linear functions, and also in slope-intercept form, y equals mx plus b. So the first thing we have to make sure we're comfortable with is what is a linear function? And a linear function is literally when you graph it, it creates a line. So a function when graphed that creates a line. All right, so very simple. If we had something like that, and this was our graph, that would be a linear function. And I also have in here, well, what is y equals mx plus b? Again, that is slope intercept form. And we're going to work with slope intercept form a lot. And again, this m is the slope, and this b is the y-intercept. The y and the x will always stay as variables. All right, so in slope-intercept form, that y and the x are always variables. Okay, so let's talk about slope. So what is slope and how can we find slope? So slope represents how steep our graph is. And so if we want to describe slope, we could have these different options. This one would have a positive slope. And it's moving from the lower left to the upper right. This would be a negative slope. A horizontal line is a zero slope. So we can have a horizontal line be a linear function that has a zero slope. And what that's saying is no matter what x input I put in here, my y value in this one will always be 2. So no matter what x, I'll just leave it as a variable. If I thought of it as coordinates, no matter what x I put in there, my y will always be 2. So in slope-intercept form, y equals mx plus b, no matter what I put in there for x, this will always equal 2. And then the last one, this has an undefined slope. And another thing while we're talking about slope, remember slope is rise over run. So if we were to look at this graph here on the far right, I could say, well, if I went from this point to this point, I rose 1, but I didn't run any horizontal direction, which is 0. Anytime you divide by 0, that's bad. We can't have that. We cannot divide by 0. That's what makes it undefined. So a vertical line has an undefined slope. All right, and if we want to look at equations, for example, so I said, what is the equation of that graph on the left? So this one right here, the equation would simply be y equals x, because I have on here, I have a slope of 1, and my y-intercept b is 0. So it's y equals 1 x plus 0. So I just simply write y equals x. Let's actually do some graphing. So if I want to graph negative 2x plus y equals 1. Well, the easiest thing to do is put it in slope-intercept form, because then I can figure out what the y-intercept is, and I can recognize what the slope is, and I can graph from there. All right, so if I were to write this in y equals mx plus b form, I'm going to have y equals, if I move this to the other side, I'd have to add 2x, so it's a positive 2x. The 1 is already there, so I'm going to leave it as a positive 1. So now I have y equals 2x plus 1. From this, I can recognize, well, my slope is 2, and my y-intercept is 1. And so I'm going to plot 1 here as my y-intercept, and my slope is 2. Again, rise over run, and so this is really 2 over 1. So I'm going to rise 2, so 1, 2 over 1, Now plot my point. 1, 2 over 1, 1, 2 over 1. But I could also go down to left 1, down to left 1. And so this creates my linear function. Looks just like that. That would be the graph. Let's do another one where we write the equation in slope-intercept form, which is a little more involved. We have some division going on. So again, I want to get the y by itself. So I would add 2y to get that positive. So I have 9x equals 2y plus 10. Well, I want to get the y by itself, so I'd subtract 10 and subtract 10. And so I have 9x minus 10 equals 2y. I need to get that by itself, so I divide by 2 and then divide all of this by 2. And so from here now, I have just a y on the right, but then I have 9x minus 10y. So this 2 is underneath the negative 10 and underneath the 9x. So when I write it this way, I'll say this is performing heart surgery, because this blue circles that I just drew makes it look like a heart. And so I have to take each one and divide it by 2. So this is 9x divided by 2 minus 10 divided by 2. And the reason I'm doing that is, remember, I want it to be in y equals mx plus b form. And so rewriting from down here, I'm going to have y equals 9 halves x, because if the x is in the numerator, 9 times x divided by 2 is the same as 9 halves times x, because really this is still over 1, plus my b, negative 10 divided by 2 is actually a negative 5. So now I have 9 halves x minus 5. From this, I can now recognize, okay, I have a slope of 9 halves, and I have a y-intercept of negative 5. From earlier on, if we hadn't done that heart surgery, from here, it's harder to see what the slope is and what the y-intercept is, because I have an expression 9x minus 10 all being divided by 2. What I want to do, I want to perform that heart surgery to break those apart, and so I can clearly see, okay, this is the y-intercept and this is my slope. All right, so that's it for section 2.3. So your assignment is page 78, numbers 9 through 15, the odds, 17 through 21, and then 23 through 39. So this is going to involve some graphing on these ones. Make an accurate graph in your notebook. I know you don't have graph paper to work with, but make an accurate graph in your notebook on the problems that ask you to graph. Have those done and submit prior to class tomorrow. So due by 8:56 on Tuesday, 12/8.